To end this section, we're going to look at another way to kind of help multiply some of these radicals together. And one way to multiply them and reduce them down. What I'm going to do is, same index, I can multiply them through. So this becomes the square root of 45. Well, it could be done unless for some reason there's a perfect square in 45 somewhere. And there is. 45 is actually a 9 times a 6. No, it's not. It's a 9 times a 5. So I'm going to write that down as 9 times a 5, or the square root of 9 times the square root of 5. And now you can see where I'm going. 3 square root of 5. Yeah, 3 square root of 5. Let's look at another example to see what we got it figured out here. Let's try 7, the cube root of 4, times 5, the cube root of 6. I have like indexes. There's both cube roots in there. I have some constants on the outside. So I can multiply those guys. 7 times a 5, that's a 35. And then I have the cube root of 4 times a 6, which is a 24. So 35, that's done. Cube root of 24, don't know what the cube root of 24 is, but I do know that the cube root of 24 can be the cube root of 8 times a 3, and the cube root of 8 times the cube root of 3, the cube root of 8 is a 2, and now I'm starting to reduce it down. 35 times a 2, which is a 7, times the cube root of 3, and there's my reduced answer. 70 times 3 cube root of 3, or the cube root of 3 might be the better way to say that. I hope that helps. I hope that's giving you enough ammunition to kind of go through and be successful with your homework. Also too guys, there's a ton of helps in my math lab too, so don't feel free to use everything you can, because your goal is to understand what's going on here so that you're able to use these tools to learn more and better and greater and newer things.